Okay, so very good morning everyone and welcome to the chemistry class. I hope you people are keep on revising the topics which we have already covered. Okay, and this week we actually have the 3 classes, so I am very happy. I hope you people are also happy that we are having more chemistry classes this week, right? So what we were doing, we were having the topic of the general organic chemistry, GOC is there. And I hope that you people are solving the questions also, okay? And yes, because when we'll complete the complete acidic strength and the basic strength, then I'll share an assignment with you, and then you can solve those questions, right? Shillong is there. Shillong, can you please raise your hands? Oh, a sunny day is there in Shillong, I guess. Can you please raise your hands, everyone? No sunny day. Okay. Then how is the weather? It's kind of very yellowish color I'm able to see from the screen. Or might be there some cloudy weather is there. Shillong? Yes ma'am, very beautiful cloudy weather is there and you are teaching us the chemistry. We have to study, okay? Let us start. I guess in the last class we were talking about the acidic strength, right? Okay, just tell me one more thing. How many of you are revising, like regularly revising your chemistry notes and solving the questions? Raise your hands. How many of you regularly revise your notebook? The lecture notes, okay? The lectures which we are, keep on revising here, and the things which we study in the class. How many of you revise? Raise your hands. Nobody is raising the hand. Very good. So beautiful. Nobody revises the lecture notes. Okay, I'm not asking daily. CC Pur is also there. So we will be happy if we could have a very brief orientation or something. We have a new student joining in today. Okay, CC Pur, so how many students are there total? No problem. CC Pur Center, we are now discussing, the general organic chemistry. It is like we haven't started any chapter, but these are the very important effects that we will be going to see further in the reactions, okay? Okay, I'll tell you I will summarize it, okay? Don't worry. And it's not like that everything is related with the previous lectures. And I request that new student from the CC Pur, because one student was already there. Now, just take the Xerox copies of them, or you can note down the lecture note, or I think we have shared the spreadsheet also. I will make sure. And in that spreadsheet, this is for everyone, for you Shillong also, okay? Like in each WhatsApp group, we are sharing the spreadsheet in which all of the links of the previous classes are there, okay? And what we have done, we have written the chapter name also. Along with that, there is the link of the class with the date. Along with that, we have also written the topics which we have covered in those particular lectures, okay? Like all of the topics of one particular lectures are already been written over there. If let's say anybody missed the class or you are not able to understand that particular topic, please refer those videos, okay? They will be giving you a lot of benefit, okay? CC Pur Center, I hope these videos will be useful for you also, okay? But still, if you find any kind of difficulty, if you are not able to, let's say gain anything from that video also, obviously we people are always here, so you can ask me the doubts either in the group or on the personal number also, okay? Clear? CC Pur Center. Okay, then let us start. I'm just writing the few topics name here, CC Pur Center, so that you will be getting the idea. We have done the effects, okay? So we have covered the inductive effect. We have covered the resonance. These are the very basic things. Already you know, okay? So we have just done these things. Along with the hyperconjugation we have done. These were the effects, okay? And in the last class we were talking about the acidic strength. For your sake of, revision, I will be revising the acidic strength here, right? Is this clear to you, CC Pur Center? Just write down so that I get to know. I'm just saying that these are the topics we have already covered, and in the last class we have covered the acidic strength also. We are just going to revise the topic of the acidic strength, right? Now, how you already know that what is an acid. I have told you the definitions in the last class itself. So whenever we are talking about the acidic strength, always remember that how you have to solve the question. Either they will be asking you for the orders, right? So what you will be doing, you will be writing like, whenever any compound has the tendency to give the H plus ion, it means that is a very good acid, okay? Any compound which have the tendency to give the H plus ion is a very good acid. For example, let me write, like we have the HF, let's say, and HF gives the H plus ion and I have the F negative. So yes, I know that fluorine is an electronegative atom and the electronegative atom can keep the negative charge over itself and thus stabilizing the anion. So we have done this thing that the acidic strength is directly proportional to the stability of anion, right? Like, if this particular anion is becoming stable, if this is a stable anion, then obviously it wants its reaction to proceed in the forward direction. Obviously HF wants to break into the ion so that it becomes a stable F negative ion, okay? So this is the way how you will be solving the question. So always remember, if anyone wants to become a very good acid, what work it will do? It will say, see my H plus, you just go away. I want to become a stable negative conjugate base or a stable negative anion, okay? So this is the main idea. Alright, CC Center, I hope you are getting it, right? Let's do one question, you will get the idea, okay? Everyone just do this question, which will be, you have to find the order, like the questions we were doing in the last class, okay? Find the order of the acidic strength. Either I can write acidic strength, either I can write acidity, both are the same things, okay? Or if I want to write the Ka order, that is also the same thing, okay? So you have to find the order of acidic strength, or you can write the Ka. It's the equilibrium constant we have already discussed. So I'm writing the first question here. Let's say if I have, let's take the simple examples. NH3, H2O, HF. I'm just writing so that CC4 will also get to know, okay? Solve these questions, tell me the answer very quickly. Very easy questions, just the similar questions we have discussed in the last class, right? CC4, I would appreciate if you people give me the answers, okay? And I hope the earlier student will be helping the new student. This is how actually the things work, What is the answer? What is the answer? CC4 center. Okay, Shillong is giving me the answers, right? What about the second one? Is it HF? Yes, it is HF. You have to write the orders, okay? You have the ammonia, CC4, you have H2O, you have HF. Now, just to explain you, because you are new, just to explain you, now I want to find out the acidic strength order. What will I do? I know that what is a good acid which will give the H plus ion. So, remove the H plus ion from all of the compounds, right? So, I will be getting a NH2 minus, I will be getting a OH minus, and here I will be getting a F minus, right? So, this is it. So, once you get the anions now, then you have to check that which anion is the more stable. Because for the stabler anion, that particular compound wants to give the H plus ion as soon as, and in order to become the stable conjugate base, okay? When I'm saying the stable conjugate base, it means I'm talking about that particular anion, right? So I know that fluorine is the most electronegative atom, and it can keep the negative charge over itself, so it is stabilizing the negative charge. So this is the most stable anion here. Most stable anion. So that is why the corresponding compound will be a very good acid, right? So the order will be like this. HF, H2O, NH3. CC4 center, clear to you? I know that Shillong knows the answer, but this is for you. You are getting it? Just write down quickly, okay? Now for the second question, like we have the acetic acid, okay, and we have the formic acid. So this is the formic acid, although we have done the order of phobia in the last class, okay, but if let's say, no, you don't remember the order, what will you do? This is the acetic acid. Now look at the screen, CC4 center, look at the screen. You have to remove the H plus ion, you're removing the H plus ion, you got the negative charge, you got the negative charge. Negative charge is present on the oxygen itself, right? Now, we have a CH3, CH2. Methyl has the nature of electron releasing group, okay? Now, it is giving the electron density, but here we don't have any methyl. Nobody is giving it, right? So, methyl, see, we already have the negative charge and we want to make it stable. But instead of making it stable, this methyl group is giving the electron density and destabilizing it, okay? That is why this is the formic, the anion corresponding to the formic acid will be the more stable one, and this is a very good acid, okay? I hope there is no doubt. Now I hope you are able to see that it is very, very important to remember that what is the nature of any particular group. Whether any group is electron releasing group, whether any group is electron withdrawing group. And that all things we have discussed in the previous classes, okay? So it's now your duty to look at those videos and get to know about them, okay? Now again, in the last question we have the phenol and we have an alcohol. First of all, this is a phenol and this is an alcohol, okay? Now what will you do? CC4, you want to try? Tell me the answer quickly. What will you do? Remove the H plus ion. You remove the H plus ion, you got the negative charge. Basically, you have to check that which negative charge is more stable. There are the various factors of checking it. Now, I am able to see that this negative charge, like we get this particular type of compound, na? Now, I am able to see that when we have a negative charge on oxygen, it goes into the ring. I should draw it here. Like there is the negative charge, now it has the tendency to perform the resonance. We can say that in this particular compound, that this one, this negative charge is stabilized by the resonance, okay? So it is stable negative charge, that is why the corresponding acid will be more acidic. Clear? Any doubt anyone? Shillong, any doubt? CC4, any doubt? I hope this is clear to everyone, right? Let's do one more question, then we'll study the new topic, okay? Try one more. Try this question, tell me the answer. What will be the answer this time? You are able to see the benzoic acid here, right? You are able to see the COOH here. Then I have made some of the groups here. Now what will you do? The same technique you have to apply CC pool. Remove the H plus ion, you get the negative charges, then you have to check that which particular anion is the more stable one. Second, first, third. I got the answer from Shillong. Yes, the answer is correct. And one more thing I want to tell you, Shillong, many students, they do get confused, When, like I was teaching here, one student asked me the question, look at the screen. One student asked me the question that, ma'am, in the third compound, we have 2 acidic H. So that will be the more acidic. Do you think so, Shillong? Raise your hands. I'm saying like in the third, your answer is correct, no doubt. But yes, sometimes the people do apply this type of concept. This is wrong, okay? That, ma'am, we are having the more number of acidic hydrogen. No doubt the number of acidic hydrogen are more in the third compound, okay? But we cannot say that this is the more acidic one. Now what I'm saying, we have to do the same trick. Remove the H plus ion, got the negative charge. Remove the H plus ion, got the negative charge. Remove the H plus ion, got the negative charge, okay? Now what you have to check, see, this is a simple benzoate now, okay? This is a simple benzoate now. Here we have the cyanide. Cyanide is electron releasing group. It's an electron withdrawing group. Okay, CC pool, you have to take care that which group is electron releasing, which group is electron withdrawing. Okay, now I am telling you that cyanide is a kind of an electron withdrawing group. This is the OH because the oxygen has the lone pair over itself, so it can perform as an electron releasing group. Okay, so both will show the resonance, but cyanide will pull the electron density towards itself and the OH will give the electron density to the ring. Okay, now what will you think? That which type of negative charge is more stable? Tell me, CC Pur, I'm waiting. What do you think? Which negative charge is more stable? Quickly write down your answer. Shillong is waiting, CC Pur center. We already have the negative charge. Which group, I'm asking that which group do you think that will be stabilizing that negative charge? It's very obvious that we already have the negative charge. So the groups which are pulling the electron density towards itself are stabilizing it, right? So what should I write? I will be writing like second. I will be writing like second. Okay, because it is stabilizing it. Yes, CC Pur, then it will be first. Then in the last we will have the third. Okay, I hope you got the concept now, right? Third will be in the last because OH is electron releasing group. It is destabilizing it. Okay, so I hope everybody has done. Now let's do one more question. Question number 5. You also try Shillong. This is also a very good question. CHO, okay, I have written CHO here. Then this is a simple benzoic acid here. Try this question. I have SO3H there, right? First of all, you will be telling me that which is the most acidic one. You have to find the order. You can write simply the 1, 2, 3 and then find out the order. And before solving this question, tell me one thing also. Before solving this thing, tell me one thing. I'm making the 6-number question although, but it will be helpful for you. You have to tell me that benzoic acid and sulfonic acid, which is the more stronger one? Which is the most acidic, Shillong? First or second? Raise your hands. Last is raising the hands, but I'm not able to see, sorry. First. Okay, how many with the first? Raise your hands. How many with the first? All of the classes with the first. Very nice. Awesome. Why? Ma'am, we are always studying benzoic acid. It is the most acidic one. Do you have any kind of, the hatred feeling with the sulfonic acid? Why not sulfonic acid? No, ma'am, sulfonic acid not our friend. It's not a very good acid. What about you, CC Center? For this question I'm asking, the number 1 is the most acidic or number 2 is most acidic? Try to apply the same fundamental Shillong. Remove the H plus ion. Okay, I'll do that. Okay. I'll do that. Look at the screen, everyone. Look at the screen. If I remove the H plus ion, what will you see? You see this kind of thing, right? If I remove the H plus ion here in the sulfonic acid, what will you see? This is a double bond O, this is a double bond O, this is O negative. Now what do you think that second will be the more acidic one? Or no ma'am, we are still with the benzoic acid. See in the benzoate, the negative charge is delocalizing. The rings are common in both of them, okay? So you don't have to compare by the common things. You already have the 2 rings common there. But I am saying that this time, this negative charge can delocalize at this particular double bond also. There are the more chances of making the resonating structure in this compound. Always remember that in the sulfonic acid and benzoic acid, sulfonic acid is more acidic, okay? Always remember this thing, that in the benzoic acid and sulfonic acid is more acidic. The reason is the negative charge is more stable. In this structure. It's very clear from the structure which I have drawn. Okay, the resonance will be more in the sulfonate. Clear now, Shillong, everyone? Okay, nice. And do star mark it, okay? Because you were having some kind of special feeling you people were having for the benzoic acid. And try to come on time, everyone, okay? Don't be late. Or ma'am, there was a wonderful weather over there. I get to know from the students. That is why I was late. And you are teaching us in the wonderful weather. This is the good thing, na, Shillong? Sisipur, is it clear to you? Now try that previous question, everyone, and tell me the answer. Now try this previous question. Sisipur Center, I hope you are okay with this. Now tell me the answer for question number 5, Shillong. Sorry, I was not able to see that. Sisipur Center, just try the question number 5 and tell me if you have any kind of doubt. 312. Yes, exactly. So that will be the answer, right? So always remember this time, many students do the mistake. They will remove this H plus, this H plus, this H plus. This is wrong. Why this H plus will go? The more acidic one will go first, na? So this will go first, okay? So the order will be 3, and in these two, how we will compare? We will compare by the same thing, CC4, okay? That we have removed the H plus ion, we got the negative charges, now this is carbonyl. Always remember that this is the aldehyde CHO, right? So it is also an electron withdrawing group. So if it is an electron withdrawing group, it will pull the electron density towards itself. The order will be 3, then 1, then 2. This is the answer. Note it down. Tell me if there is any doubt. So I hope now the concept of acidic strength is clear to everyone. You people can apply the concept via the electronegativity, size, like for the groups, anything, okay? So this is clear now. Good. Let's have the one important topic. This is a kind of an exception you will study. This is not mentioned in the NCERT, let me tell you. This is something which they ask in the, in the very good questions, okay? So at least we should have some idea related to that. So this is known as ortho effect. Like if you see the good books of the, the competition related, the NEET related, you will see this type of things there. Have you people ever studied the ortho effect in acidic strength? Shillong, raise your hands. Anyone? No, you don't know that. Okay, nice. Now what the ortho effect says, it says that whenever you are comparing a benzoic acid, and this is observed mostly in the benzoic acid and the sulfonic acids, okay, let me tell you. So whenever you are comparing, like if I have this type of question, I am comparing the acidic strength with any ortho substituted benzoic acid. I am saying it doesn't matter that which type of group it is. I can have any group, any G group. I am writing the G word here, okay. G is for any group. Whenever I am having any G group here, like if I give this question to you now, then what you people do? You will see that ma'am G will whether will be an electron withdrawing group or an releasing group, then we will find the order, okay. But now what we have to do? Whenever you are comparing any benzoic acid with any ortho substituted benzoic acid, always remember that benzoic acid will be more acidic. This will be the more acidic one, okay. This is the case. Oh, I'm so sorry. I have written in the wrong way. This is the more acidic one. Sorry. And this will also be the less acidic. This is the K order. Irrespective of the nature of the group, the ortho substituted will always be the more acidic one, right? So always remember this thing. I am writing here also, when the benzoic acid and any ortho substituted benzoic acid is compared, any ortho substituted benzoic acid is compared, then the ortho substituted benzoic acid is more acidic. And always remember that I am comparing only with the benzoic acid, not with any para or mata, okay. Then the ortho substituted benzoic acid is more acidic. Written, everyone? I will tell you the reason also, okay, that why this is happening. Either you want to write it into, you can write as the exception, or this is actually known as the ortho effect, okay. This is actually known as the ortho effect. Clear? Now let me tell you the reason. I hope everybody has written it. Okay. See now what is happening over here. Look at the screen, everyone. I have told you when we were studying the resonance that resonance is possible in only those compounds which are planar, okay, which are in one plane, okay. Like if I want to make the benzene like this, this is the benzene, these are the pi bonds, it's a planar structure, it's simply, all of them are sp2 hybridized, the geometry is trigonal planar, so I can make it like this, okay. If I go into a bit detail, it would be like this, I am trying to make a p orbital diagram. Pure p orbital always make the pi bond, everyone. So all of the p orbitals are in a single plane. Are you able to see that? And like this, they are having a double bond. This is the double bond. This is the double bond. Okay, I am just only showing a p orbital diagram. This is the p orbital diagram of benzene. Okay, don't get confused. So it's a p orbital diagram of benzene. Now if I want to extend it till the benzoic acid, how will it look like? I was having like the double bond like this and OH. So I'm just telling you that all of the atoms, all of the double bonded p orbitals are in one plane if we are considering the benzoic acid, obviously. So if I remove the H plus here, look at the screen, I am removing the H plus ion here because I am trying to convert it into the acid. We know how to check the acidic strength, we remove the H plus ion, we get the negative charge, right? Now what is happening over here? If I want to draw the resonating structure also, it's like something like this. I'm just trying to show you the resonance here, okay. You put the electrons here, okay. You put the electrons here, it will look like this one. Look at the screen, keep on looking at the screen. It's like negative here. Now the carbon got the positive, right? So what will you do? You put the electrons here now, okay. Like in the ring, we are keep on delocalizing the thing. So it's like this, okay. So that's how this positive charge keep on delocalizing in the ring. This is how we can show the resonating structure. I'm just telling you that the complete resonance is present in the particular benzoic acid and ion, and that is why all of the p orbitals will be in one plane, because everywhere there is the resonance, right? So there is the p orbital, there might be a p orbital, and they will be having like this pi bond, okay? So this is what I am telling. So everywhere there is the resonance, everywhere there is the resonance, the electrons are delocalizing, okay? This is what actually happening. Clear to everyone? First of all, raise your hands along. Just a brief idea. I hope this is clear to everyone. Very nice, very good. Now what happened in the case of an ortho-substituted thing? Look at the screen. What happened actually is, when I have an ortho-substitute, this was the case, I was already having this type of system, and if I put, a G group here, now you are able to see that there is so much kind of a steric crowding is there, okay? Because of the presence of any particular group at the ortho position, there is a lot of steric hindrance, there is a lot of steric crowding. So there will be a lot of repulsion in between the carboxylic group and that particular G group, which causes, what will happen? See, two people are sitting so close to each other and they are not sitting comfortably. So what will happen? Obviously, they will push themselves, okay? And then what will happen? Like a kind of a lot of repulsion will be there, which causes that particular carboxylic group to go out of the plane. So it will go, this group will go, it will go out of plane. So if it goes out of the plane, see what will happen? Don't you think it will look like this thing? I was having the double bonded system. So this time I am trying to, because obviously it's a two-dimensional thing, I'm making it like this. Are you able to see that? So it's this kind of system I'm having now, right? So what is happening? The ring was like this, and earlier the carboxylic group was also in the same plane. This time this is the ring, and in this direction I got the carboxylic group, okay? So, and this G group is same, present over here. So what will happen to the orbitals? What will happen to the orbitals? This time the orbitals will go out of plane. See, these orbitals are in the single plane as they were earlier. These are in the single plane. But this carbon and oxygen orbital, don't you think it will becomes like this? So are you able to see that this time there will not be a proper resonance, okay? So this time what will happen? There only be the resonance, like this was the system, this is the double bond O there. So there will only be the resonance in this part. There will only be the resonance in the carboxylic part. So due to the presence of this G group, like the carboxylic group will not get the resonance here. And we already know that this resonance is a very good, where when we have the negative charge on the oxygen and oxygen, this is a kind of an equivalent resonance. So this is a kind of an equivalent resonance which is happy to have. That is why this negative charge is more stable. That is why this corresponding acid is more acidic. There is an equivalent resonance, therefore it is more stable. Therefore, the compound is more acidic. Okay, I try to explain it in a bit detail, but if you simply write this thing, that the group goes out of the plane, and that is why the resonance diminishes. Okay, so that is also enough. Now tell me if it is okay, Shillong, raise your hands. CC Pur Center, you also let me know. Okay, good. So just note it down, okay? Note it down. I'm keeping the screen here. First you can draw the only carboxylic acid thing, and you can write that resonance is present everywhere. Carboxylic group is having the resonance with the ring also. Here you can write, I am writing it. The carboxylic group have the resonance with the ring. But when it goes out of the plane, then there is, and you can write that due to the G group there will be a repulsion, and that particular group will goes out of the plane. Sisipur, I hope you are okay with this. Done? I'm scrolling it, okay? And here you can write that when it goes out of the plane, then the resonance with the ring diminishes. Sisipur Center, this is clear to you also? Repeat. Okay, first of all write it down, then I'll repeat again, okay? Write it down quickly. Okay, I hope everybody has written. Now just a brief, what we have done. Look at here, CC4 center. A very simple thing, a very normal thing, that whenever you see any benzoic acid compared with any of the ortho-substituted group, the ortho-substituted will be the more acidic one, okay? Now what happened is, now how this was a very good acid, although this is also a good acid, like this simply benzoic acid. Because when we remove the H plus ion, we get the negative charge and whole ring is in the resonance, okay? Whole ring is in the resonance. So it's something like this one, like this is how I have drawn the resonating structure, okay? Like we have broken that bond, here we get the negative and the ring is giving the electron, and it's how the positive charge will be delocalizing in the ring, okay? And one more thing, like when you will see that video of the resonance, you will understand it more, okay? So I am simply saying that in the simple structure of benzoic acid, when we get the anion, the resonance is possible all over there in the structure, okay? But now what happened here is, due to this particular G group, what is happening? This G group will be having the repulsion. You are having two bulky groups, sitting together. So there will be the repulsion. So there will be the fighting among them. So what happened? This group will pushes the carboxylic group and it will goes out of the plane. Goes out of plane. So this is, see, this is an out of plane, okay? This is a single plane over here and this goes the out of plane. So when it goes the out of plane, CC4, what happened here is that now this particular group cannot have the resonance with the benzene. It has to perform resonance within this particular structure. Look at here. Like this is the one resonating structure, the other will be like this. Here is the O negative, this is the double bond, okay? So it will have the resonance only like this. And it is happy to have the resonance like this, because in every structure we are getting the negative charge of the oxygen, and oxygen can stabilize the negative charge over itself, okay? So I know that it will be difficult because you haven't, studied the previous lectures. So I just want, once you get the resonance, this is very easy. So you will automatically get it, okay? So try, because you have to read by your own also, okay? But still, if you find any kind of difficulty in a CC4, you can message on your group, okay? All of you are there on the group. I am also there on the group. So just post a message. I'll explain it again, okay? No worries. I hope this is okay with you, right? Now let's do a question, okay? CC4, you will understand more. Let's do a question. You also do this question so long. Let's say here is the nitro group, okay? And I am giving you this also. Obviously, if I give you only the first and the fourth compound, what answer you will say? If I only give you the first and the third one, you will say, all of you will say, ma'am, third is the more acidic one, right? because it's the ortho substituted. But try with the para position also. So you have 1, 2, 3. 3 compounds there. First of all, try to solve the question so long as you were doing. Like the group nature you have to see, and then definitely you will get the answer. Yes, this is correct. Good. See, CC center I'm explaining. You can just look at the screen. So how we will be doing this question? I know that everywhere this H plus will go and a negative charge will be there. H plus go, negative charge is there. And there is automatically, this is at the ortho position. Obviously here also the negative charge is there. But I am saying, now look at the screen. Let's forget about the ortho effect for a time. Okay. I'm saying just for a second, let's say we haven't studied the ortho effect. So what will you say? You will say, ma'am, this is an electron withdrawing group. NO2 is an electron withdrawing. Here it is also an electron withdrawing. Now, Shillong, one more thing we can have, Now, both are having the electron withdrawing via the resonance, okay? Or mesomeric effect we have done, okay? Sisipur, you remember, I guess. So, mesomeric effect we have done. Both are pulling the electron density via the resonance. So, resonance is same at the position. Always remember, this is a very important concept. If I am saying that both are electron withdrawing group and both of the NO2s have the minus M, so minus M does not depend on the distance, okay? So minus M will be same in the second and the third question. But this will also be having, like both are having the minus M, this will also be having, if you have the same minus M, then you will check for the inductive. This will have the minus I, this will also have the minus I. And this will have the minus I more because of the distance. It is more closer to the carboxylate, okay? So from this also you can just simply check, or either you can apply the ortho effect also, that this will be the more acidic, right? So the answer will be 3, then it will be 2, then it will be 1. Basically we are talking about the stability of the negative charge. So this is what I am saying, right? I hope this is clear. Shillong, clear everyone? Don't get confused, okay? Okay, nice. You wanna try one more? Let's try one more. This time I am giving you methyl, okay? This time I am giving you methyl. This is also a very good question, okay? Think about it. You have to check for the ortho effect as well. And then you will give me the answer. What is the answer? Methyl, what type of group methyl is? Methyl is to give the electrons. It's an electron releasing group, okay? You have written Shillong 312, 312, 321. 321 is correct. How many of you are with 3, 2 and 1? Raise your hands. I'm saying that how many of you are with 3, 2 and 1? Only one student. Erini, right? What about the other people? Girls, second last desk. Last desk is also there. Although you are not sitting on the desk, these are the chairs. What about that? What about the question? CC Pur, what is your answer? 3, 2, 1. Shillong is saying 3, 2, 1. See, what will happen? Look at the screen. This is a methyl group. Everyone, first of all, remove the H plus ion, will get the negative charges. Then I'm saying that methyl, it's an electron releasing group. Instead of stabilizing it, you are giving the electron density, right? And here what is happening? Here it is also giving the electron density. So if I just forget about the ortho effect, now the answer will be something like, it will be different, okay? But we, at the same time, we know that here we will have the ortho effect. And ortho effect says that particular compound will be the more acidic one, okay? Yes, Sisipur, very good. Your answer is correct. So it will be 3, then it will be what? It will be 2, because if I compare only in the second and first, what will happen? What will happen? This will goes in the last, because it is destabilizing it, okay? So it will be 3, 2 and then 1. Sometimes the people also do the question like this. They first of all find out the normal order, like by just taking the groups and what is releasing, what is withdrawing. They simply check out the normal answer. And then according to that, they just, fit the ortho effect in between. So you can also go for that. So I hope this is clear. Now the ortho effect is clear. Now you can do the questions of ortho effect also. There is one more very interesting concept here. But let me ask you that question and then I will explain it, okay? So there is also one. You can, write all these things in the note. Where were we? Everyone look at the screen. We have started the ortho effect now. I am writing note here. I am writing the note here. So just make the first point in the note of the ortho effect itself, okay? I am saying make the first point here of the ortho effect. Write down the note as the heading and the first point will be your ortho effect, okay? And we have discussed the ortho effect. Now I am talking about the second effect, okay? But before writing the heading, just leave a few, 1, 2 line there. I am asking you the question. First of all, you people try the question, then I will explain then how to do it, okay? Excuse me. First of all, you people will try it, then I will explain. Let's say we have the NO2. Try this question. A paranitrophenol, metanitrophenol, orthonitrophenol and a simple phenol I am given. One very important thing, everyone, do not apply ortho effect in this particular case. Okay, do not see that the second will be the most acidic one. The reason is ortho effect is observed only in the benzoic acid. I am taking you back here. I am writing here also, it is observed in, it's a blunder people do, carboxylic acid and in sulfonic also. Although if they will ask you the question, in the need the questions only come from the carboxylic acid, okay? So you don't see like that wherever you see the ortho position just put it at the front. No, don't do that, right? So it is observed, the ortho effect is only for the benzoic acids and for the sulfonic acids, only for them. In phenol, there is no ortho effect. Okay, I hope everybody has written. Clear? Now let's get back to the question. First of all, you people think, then I'll tell you how to do it. I think in the electrophilic aromatic substitution, in the haloalkanes chapter, you have done the preparation. Sorry, in the phenols, there is also the preparation. Think about it. You know that NO2 is an electron withdrawing group. It has the minus M effect. It has the minus I effect. Then how you will be doing the question? Oh, I got the answer from Shillong. 1, 3, 4, 2. Why you have put the second one into the last? Can you tell me, Shillong? Oh, you got the trick. I'm just asking that why you have put the second one into the last. You have put the second one in the last and you are saying that ma'am, phenol will be more acidic but not the orthonitrophenol. Why? Have you ever studied this order before? Or it's your own creativity? If anyone having any other answer, then they can also write. The girls at the back, I hope you are discussing the same question. So if you find the order, you can tell me, okay? CC-Pur Center, what is your answer? CC-Pur, have you ever studied this? This is actually a very famous question they ask. When I write the second point heading, then definitely you will get it. Because obviously in orthonitrophenol, in paranitrophenol, something special is there. You have studied it. Different answer. 1, 2, 4, 3. Wait. 1, 2, 4, 3. 1, 2, 4, 3. Okay. 1, 3, 4, 2. 1, 2, 4, 3. Let's see which is the correct one. Look at the screen how to do it. First of all, this was a kind of a special case of hydrogen bonding. Okay. So here there is a kind of hydrogen bonding will be there. Which type of hydrogen bonding will be there, I'll tell you. Now everyone look at the screen first of all. Let's say that I haven't told you about the H bonding. Nothing is there. You know how to solve the question. Let's do that how you people will be solving the question. Okay, look at the screen everyone first of all. I know that this is the nitro, right? Nitro is an electron withdrawing. It will take the electrons towards itself. I know that this is a minus M group. Okay, via the mesomeric I am saying that if I perform the resonance here, it will take the electrons towards itself, right? Now here also it will perform the minus M, and I have told you that minus M is same at both of these two conditions, right? At both, because resonance is not distance dependent. If I do the resonance in both of the structure, now I will be getting the same structures, right? So what difference here we can see? We can say that there is also a minus I effect. Inductive is also negative. Here also there is a minus I, right? Okay, and here the minus I is closer because inductive effect depends on the distance, right? So by having that, don't you see that so long this will come in the first, but hold on, let's see. And this is at the matter position, it will not have the mesomeric. Very important point everyone. mesomeric or resonance you cannot observe at the matter position. It will only be having the inductive, because inductive doesn't bother. So here we will be having the minus I, okay? And in the last one there is nothing. There is a simple phenol. Now what is happening? I am just writing the name. This is the para, this is the ortho, this is the matter, and that is the simple phenol. If I simply write the order this time now, what I will be saying that, what do you think, Shillong, which should come first? In the first and second, the mesomeric effect is same, and the inductive is more closer in the case of the second one. So, do you think that I should write like this? Or I should wait, because Shillong is writing something. Which should come first? What do you think? Yes, right. Now look at the screen. I am writing like ortho will be there, then it will be the para. I'm not using 1, 2, 3, I'm writing like ortho. Ortho will be there, then it will be the para, then it will be the matter, because it is also a minus I, na? So third will be there, Shillong, okay? So it will be the matter, and last in the phenol. But listen to me, the story hasn't ended over here, actually, okay? Because here what actually happens is, so this is the order which should be there according to our knowledge, okay? We understood the minus M, minus I, everything, so this should be the order according to our knowledge. But what happens now? Now everyone look at the screen, now. What happens here is, because this is a orthonitrophenol, you remember that there is the chances of intramolecular H bonding. This is the oxygen, I am making the structure, okay? This is the acidic H and there is the oxygen, there is the chances of intramolecular H bonding. So if the hydrogen is getting engaged into the H bonding, will it allow the hydrogen to go away? Definitely not. Can it become a good acid then? Definitely not, okay? I am saying that this should be the order. But what happened? The orthohydrogen, that acidic hydrogen in the case of orthonitrophenol, it will get engaged into the hydrogen bonding, that too is the intramolecular H bonding. So it will not allow its hydrogen to go away and act like an acid. So what will happen, and many times students do the mistake as the first order you have written Shillong, you put the ortho one in the last. Don't put it in the last. Just look at the screen. You have to make a one jump here, So ortho will get one step back. So what order I will be getting? It will be para, then ortho, then matter, and then phenol. This is the order. And many times the student, learn the order even, that it's a POM, P-O-M, okay? So if you want, you can go by that. So just remember, and it's a very, very important question, generally asked in the NEET exam also, and sometimes in the state level exams. So just write it down, and this is the best way to understand it. I hope you got it. Shillong, any doubt, raise your hands, I can explain it again. Clear? Note it down. Still any confusion, you can let me know. And do write this thing, okay? That there is the chances of, this is an intramolecular H bonding. And if you can write that due to the intramolecular H bonding, the hydrogen will not go away. The third and the fourth, there is no problem na Shillong. Look at the screen. In the third and the fourth, in the third one, we are having a nitro group over there at the matter position. So nitro is, obviously it's a taking. It will take the electron toward itself. So I guess shouldn't resonance be come before the inductive? Definitely. But I am saying that what resonance you are checking in this particular case. See, in this last one, there is no nitro. There will only be the resonance with the ring. This negative charge is here, right? This negative charge is here on the oxygen, and there will be the resonance with the ring, no doubt. And here also, it will go away. There is a negative charge. The resonance will be the ring is as it is. But extra, we are getting a minus I effect, okay? that resonance which you are talking about, na Shillong, that is in both of the case, in the third also and in the fourth also. Like the O negative charge can delocalize into the ring. But we are getting the supplementary extra beautiful thing here, that we are getting a nitro group at the matter, which will be pulling the electron via the inductive. Are you getting? So here something is resonance plus inductive. And in the last one we are getting only resonance. Clear now? Erini? Okay, nice. So actually the first answer was correct if you just, swap the position of fourth and third one. CC-Pur center, where are you? Where is CC-Pur? Clear? I guess today you are studying very new things today in the class, right? Like the H bonding, and these are the complex questions in the acidic strength actually, So H bonding concept, just remember it, and the ortho bonding concept, okay? So this is the actually important thing. Okay. And one question I'm giving you for the homework. I'll give you the homework for these questions also, but this you will try. There is a compound which is known as a squaric acid. How many of you know? Anyone, any idea? No idea. So it means I have to draw the structure as well. This is the kind of structure, And it's also a very good acid. It is more acidic than formic acid even, okay? So there are the question that how many resonating structures will be formed from the anion of the squaric acid, or why this is more acidic as compared to the formic acid. Means I just want you to know that there is something like this in the universe, and it do have the acidic strength more than the formic acid, okay? If I write the anions of that particular acid, how will it look like? O negative, there is a pi bond, O negative, there is a double bond O, there is a double bond O. Everyone, now you people will tell me, this is the homework, you will tell me here the resonating structure of this particular one. Try, okay? Because actually here the three bonds, I'll give you a little hint, look at the screen, I'll give you a hint. Then you people will try to make the resonating structure. How you people will draw, Look at the screen. This is a double bonded system, right? Put the electrons here. You put the electrons on the oxygen, here you will get the positive charge. Now put the electrons here. Here you will get the negative charge. So that particular double bond or in the ring will also delocalize, okay? And once you get the negative charge, you will get the positive here, then put the electrons here. So just make a structure in which you can show the arrows, and you will be drawing the resonating structure by yourself. So at a time three arrows I have shown. So 3 type of delocalization will proceed at a single time. Okay, this is a very good question. So you can try squaric acid, and you people will find that how many resonating structures will be possible for squaric acid. Okay. So you will tell me the answer on the group. So I guess all of the important things we have already covered in the acidic strength, that is covered. Let us start with the basic strength. Should we take a break, or we'll start the basic strength? You want a break? Or no ma'am, we don't want a break. Okay. So no break, right? So we'll take a break for 10 minutes, and after the break we will be starting with the basic strength. We'll talk about the basic strength. It's very similar to that actually. And after that, one very small example, we'll talk about a tautomerism little bit, then we'll proceed further. Okay, so let's have a break for 10 minutes, and I hope everybody will be back after the 10 minutes. Okay. Okay, so I hope everybody is back after the break. So let's start with the basic strength, okay, and it's actually the reverse of the acidic strength, okay. There will be the orders that find out the order for the basic strength. So you have to check for the Lewis base actually, okay. So let us start. Long, I hope everybody is there, and in CC-pur also, okay. Yes. So have a look on the screen. So we have the basic strength here. In the basic strength, what we will be talking about, it's simply, I have told you that there were the three kind of definitions. So we have done the Arrhenius basis. There is a definition for the Arrhenius base. There is a definition for the Bronsted-Lowry base also, okay. The Arrhenius bases are all those like NaOH, like KOH. A very common definition which we are studying from very junior classes, that any of the compound which has a tendency to donate the OH negative or to donate the hydroxide ion, all those comes under the category of the Arrhenius bases, right? And there is the one more concept of the Bronsted-Lowry bases. Now what are those? Now Bronsted-Lowry, these are the names, okay? We have already done this CC-pur center, okay? I'm just writing for the sake of revision. Like ammonia is there. Those who are the proton acceptor or those who take the H plus ion, like NH3 can take the H plus ion and it can become the ammonium, you know that, okay. Those all have the tendency to take the H plus, they will become and conjugate like the Bronsted-Lowry bases. And then the last one is of our use, we will be talking about the Lewis bases. These are the electron pair donors. Those have the tendency to donate the electrons. Very common example, water is there, ammonia is there again because they all have the lone pair, right? And what else? We can have even the RNH2, these are the amines, etc. Okay, so those all comes under the category of the Lewis bases. Like those have the tendency to donate the electrons. A very important thing. Those who have the electrons, obviously it's only they will be donating it, okay. So the compounds which will be having the electrons, more electron density. Earlier you remember in the acidic strength what we were doing? We were checking, we were saying that the electron withdrawing group were stabilizing the negative charge. Here it's very much, it's self-understood that the groups which give the electrons, which will be, increasing the electron density, they will be making a very good basis, right? So let us start. I'm just writing here. I just write this thing. Whenever you want to check for the basic strength, what you have to look for? It's the ability to donate lone pair. This we have to check, okay. Those who have a very good ability to donate the lone pair, they will be the very good bases, right? I hope this is clear to everyone. Let's try to understand it with the help of the examples, okay. I'm taking the few examples here. Number 1, I'm writing CH3 negative, I'm writing NH2 negative, I'm writing OH negative, I'm writing F negative. Now you people will tell me that which have the tendency to donate the negative charge. Obviously, now all these are the bases. They all have the negative charges. It means they have the lone pair. Now it means they have to accept the H plus ion in order to work as a base. So what do you think? Which will be a very good base? Those will give the negative charge. Okay, those will give the negative charge are the very good bases. Write down quickly, tell me the order. CC-pur center. CC-pur center, tell me the answer. Which one is the base? F negative or CH3 negative? Very nice. This is the answer, Shalom. Good. So CC-pur, I hope you also know that. The answer will be CH3 negative, then NH2, then OH, then F negative. Because it's common, See, fluorine has the negative charge. It's an electronegative atom. So electronegative atom will stabilize the negative charge. It is happy to keep that negative charge. But CH3 is not happy. So what will CH3 say? Wherever it sees the H plus ion, it will give its electron to the H plus, okay, and act as a base. So you can write that along the period Along the period, electron negativity increases. Along the period, now all of the elements are of the same period. Along the period, the electron negativity increases. Therefore, tendency to donate electron pair, this decreases. Okay, this decreases. Therefore, we can say that along the period, the basic strength decreases. And sometimes people cram these things, that along the period it decreases, down the group this happens. No need to cram, it's very much, self-understood. I'm just saying that. So tendency to donate lone pair decreases. This is therefore. Therefore, basic strength decreases. And this is all we are talking about along the period, right? Clear to everyone? Any doubt? Okay. Sisipur, you have any doubt? Write it down if you have. Now you people will tell me the answer for this one also. Your favorite question, right? Okay. Sisipur, try this question as well. Which is a very good base here. Exactly, So F negative, because we know that I negative stabilizes the negative charge, just reverse the order. So it will be F negative, Cl negative, Br negative. And also one more thing, do write that what orders you are writing. Because, after 3-4 days when you revise it, you will see what we have written. It's the order for the basic strength. Kb I am writing, okay, Kb. So you can also write Kb. Equilibrium constant, that is the Kb, right? And same thing you have to write that down the group size increases. We talk about the size in a group. Down the group the size increases. Therefore, tendency to donate electron pair, it decreases, right? Because it is stabilizing the negative charge. Therefore, basic strength decreases. So, along the period also it decreases, and down the group also it decreases. The basic strength decreases. Clear? So, I hope there is no doubt in these two questions. We have already discussed a lot of time these types of questions in the class. Written, everyone? Okay, now think about this one. I'm writing the question number 3 here. Let's say here I have NH2. Just check which one is a good base. First of all, from where you will be giving the electrons? Obviously, I have drawn the amines. Nitrogen is there. So, nitrogen will give the electrons to the H+, right? So, both of them has the lone pair. Then tell me which will be a good base. Sisipur, you can also give me the answer. No. Shillong, acidic strength increases down the group. You are getting confused with the nucleophilicity. We will be talking about the nucleophile also. I negative is a good nucleophile, no doubt. But good base is F negative. Look at the screen. HF, HCl, HBr, HI. Now what do you think, Shillong? Which is the good acid? Down the group acidic strength increases, right? So HI is a very good acid. And how do you say that this is an acid? You used to say that ma'am, I negative is more stable. It's so common, na? F negative, I negative. Which is more stable? I negative is more stable, right? So if it is more stable, will it be able to give its electron? No. F negative will give the electron, okay? So down the group, basic strength decreases. But yes, the nucleophilicity, what you are talking about, that is nucleophile, okay? That comes later on. We'll discuss that. Clear now, Shillong? Erini is confused. Take your time, then tell me, okay, if it is clear. Down the group, actually acidic strength increases, but the basic strength will not increase, okay? You can just check it. Okay, clear? Good. What about this question? Anyone other than Erini? Who will going to write the answer? Other than Erini. Let's have the competitor of Erini. What will be the answer of this question? First. Oh, girls are raising the hands first. Okay, that is nice. So first is the answer, right? Good. So what will happen here? See, this is the electron pair, this is the double bonded system. So CC4 center, what will happen? You know, both of them has the lone pair, but this lone pair is participating in the resonance. This will participating in the resonance, okay? So if they are engaged into the resonance, will they act as a base? Definitely not. Because they don't have the lone pair completely over themselves, right? So which will be the good base? This is the basic strength. KB order. Everyone, I hope you got it. Do write the explanations also, okay? That here the lone pair is delocalized. Therefore, it will not be easily giving its lone pair. The lone pair is delocalized. But in the first structure, the lone pair is localized. CC4, you got the concept? Just tell me, okay? CC4 center. So, I'm just saying that there are the many questions you will see of particularly of the amines, NH2. So, you have to check if your lone pair is participating in the resonance. If they are participating in the resonance, obviously they are not free over there. How can the H plus come and take the electrons if there are the electrons not present, okay? So they are in the resonance. Let's try one more question. Try this question. Let's say if I have okay, CH3, CH2, NH2. I'm writing one more, okay? Let's say this is the first, this is the second, this is the third. Now tell me the order. Think about it, tell me the answer. This time the girl is typing, right? One, two, and three. Can you please tell me your name? I know only the name of Erini. Tell me your name. This is how I will get to know about your names, na? That is why I always say, keep on writing the answers. Yes, the next time that boy will go. We will write the answer next time. Cane. If I am pronouncing it wrong, I'm so sorry, okay? So your name is Cane, right? No, it's not. I'm so sorry. So what if you have written CANE? I always try to apply my own creativity while pronouncing the names because earlier there was you people are new. Kenny, okay. Kenny is right. Okay, nice. So I got the two names today. Erini, I learned that, and Kenny. Right, nice. Coming back to this question, see what will happen now. How you will be solving this question? Simply you can do it. You are able to see that lone pair is present everywhere on the nitrogen. So this can be done with the help of the hybridization, right? We have already discussed the hybridization earlier. See, the hybridization for this nitrogen is sp3. Everyone, those who don't know, please look at the screen. I'm explaining again. This is the nitrogen. Two bonds are there. You remember that what is the steric number here? 1, 2, 3 and 4 because this is localized. It's fixed over there. So 4 is the steric number, okay? 3 are the bonds, 1 is the lone pair. So it means that 4 orbitals will be mixing over there, okay? That is why the hybridization here is sp3. 1s and 3p are mixing. CC4, I hope you are also getting it. Now for this one, it's CH3, CH, double bond nitrogen, hydrogen and a lone pair. Now there is a pi bond, right? We do not count the pi bond in the hybridization. So what will be the steric number here? It will be 1, 2 and 3. It means 3 orbitals are mixing. So it will be like sp2, okay? And this is cyanide. Cyanide is again, now what will happen? It's 1 and 2. So it will be sp. This is sp hybridized, okay? So you know that the electronegative atom, what is the order of electron negativity? It is sp, then sp2 and then sp3. So sp, nitrogen, can keep the lone pair over itself, making it stable. So it will not easily give its lone pair, right? So the answer will be first, second and then third. Please mention. I should write it here. Okay, so this is the order. I'm saying that please mention the hybridization in your explanation. It's very important. Clear to everyone? So this is how you can check the certain orders with the help of the hybridization as well, okay? So these were the questions. Now I'm going to give you a mixed and a combined question of question number 3 and 4. It's a very good question, In the last year exam, there was this type of question which I'm giving you right now. I hope the question number 4 is clear to everyone. I'm giving you a new question number 5. Try this one. You have this structure. You have CH3. Let's say you have this structure. Here you can have nitrogen. You have this structure. Let's say we can have this one here, yes. So I am writing here, let's say this is 1, 2, 3, 4 and 5. Think about it and tell me the answer. You have to check for resonance as well as you have to check for the hybridization. Try, then I will tell you how to do it. Anyone? CC Center, you wanna try this? What will be the answer? Five two three one one does not have any lone pair, ma'am. Which one? What happened? Okay, you're telling me the answer. I hope you're writing the ascending order, right? No, fourth one do have the lone pair. Fourth one do have the lone pair. I have not shown it, but obviously it's not necessary that in the exam they will be showing it, right? So this is the order you are writing in ascending order, which is the most basic, CC4. Okay, so you are writing the ascending order, right? Wait. 5, 2, 3, 2 and 3, and a little mistake is there, CC4. CC4, check for the hybridization, na? 1 doesn't have the lone pair. 1 do have the lone pair. That is why you are making the mistake. 1 also have the lone pair. It's obvious. CC4, listen to me. Whenever nitrogen makes the 3 bonds, now whether it is pi bond, whether it is the sigma, always after the 3 bonds of the nitrogen, there is a 1 lone pair definitely over there, whether it is shown or not. Okay. So like ammonia is there, NH3, it do have the lone pair. So if I want to write, I can simply write NH3 without the lone pair. But it's obvious, okay? Now you can just check it. Shillong has replied the answer. First, second, third, fifth and fourth. Okay. Okay. I'll tell you, then you people can match your answers, okay? Have a look. Whenever you see this type of question, now because it's very obvious and very common, these types of questions will be there in the exam. And what you have to do, always, apply the same thing. You know how to find the hybridization, just find the hybridization. Everyone look at the screen. Everyone just look at the screen. See, this is the first one, very common thing. Nitrogen is making 3 sigma bonds with 1 lone pair, that is 2, which is localized. Can I write that this is sp3 hybridized? This is sp3, right? Okay. So obviously, look at this question back. We have just written this thing, right? So sp3 were having the more basic strength, then sp2 and then sp. This is clear. Now coming back here, now look at this one. Can you people tell me what is the hybridization of this nitrogen in the second question? What is the hybridization here? Whether it is sp3 or sp2? sp3 you are taking Shillong, that is why you are doing the mistake. Now listen, it's not that this lone pair is fixed. Is it fixed? No, it is participating in the resonance, na? So it is not fixed. Steric number was total number of sigma bonds plus lone pair. Those are fixed only. Okay. So here your steric number is only 3, not 4. So you will not be counting the lone pair this time. This is sp2 hybridized, and I can write that lone pair is delocalized. Clear to everyone in Shillong? Raise your hands if it is clear. Okay? Yes. So I am saying that you will not be counting this lone pair while finding the steric number. The reason is clear because it is delocalized. Okay? Now coming back to this 3 number. This lone pair is fixed now. This is fixed because it is not going anywhere in the resonance. 1, 2, 3. This is again sp2, but the lone pair is localized. Okay? Are you getting the difference between second and third options? I am saying this is also sp2, but the lone pair is localized here, right? Now the fourth one. This is sp again, and no resonance is there. It is again localized. Coming back to question number 5. Now again, you might have done mistake in finding the hybridization here. This lone pair is participating in resonance again. Okay. So here 1, 2, it's sp with the delocalized. Okay. Everybody now getting it? Now it's very common. CC-Pur Center and Shillong. Now, which will be the most basic one? CC-Pur, are you getting it now? The first one will be the most basic, right? Because sp3 obviously will be the most basic one. Okay? Because it is having the very lesser electronegativity. So, I am here writing the complete order for the basic strength. Everyone, first of all, have a look. I can write here, this is the sp3. Now again I know that it will be sp2, and which type of sp2 should I write? Delocalized or localized? I know that for a good base there should be the presence of lone pair. So I will be writing it should be sp2, that too with the localized one. Okay? So this is the order we are getting. After that again we can have sp2, that too, because no option, so we can have the delocalized one. So this is the complete order, and after that I can write sp again, it should be localized, and after that there will be sp which should be delocalized. Now the order which I have written in the green color is very, very important, okay, because it will be applicable in all of the questions of the basic strength. So you will be doing these things, you will be finding the hybridization, and you have to check that which lone pair is localized and which is delocalized, right? Now we can find the order. So what will be the answer here? It should be first, then third, then second. I'm writing the order, you people can also have it. First, third, second, then fourth, and then fifth. Clear to everyone in the Shillong? Okay. Yes. Nice. And in the CC-Pur Center, I hope this is clear. Nice. Okay, so always remember these kinds of things. This is very, very important. Now let's proceed with the questions. We were doing the questions now. So I'm writing the 6th number. Now these are the easy one. You can do them. You will tell me, you have to tell me the name as well for this compound. And let's say if I have CH3, CH2, NH2. Basically, I have an aromatic amine and I am writing an aliphatic amine. What will be the answer? The aromatic amine and the aliphatic amine, first and second, which will be a good base? Second? Yes. So second will be the answer, right? Because in the first one, the lone pair is going on in the resonance, okay? And there is no resonance. So here I can write that lone pair are delocalized. And these are localized. Localized means which are fixed, okay? So this will be the more basic. This is the order for KB. That will be more basic. Let's write one more order. And what is the name of this compound? This was aniline, okay? Aniline. The common names are very, very important. I hope you people already know that. This is aniline, okay? So if you compare the aniline with any of the amine, aliphatic amine will be more basic. Try these questions also. You have to tell me the order for the basic strength. What is the answer? 3 to 1. So it will be, yes, this will be the answer, right? CC2 center. I hope you are getting it. So here basically, you have to check that that already nitrogen has the electron density to donate. So what are the nature of the groups now? Okay, so these types of questions are very common and everywhere. Like in the acidic strength you will see, in the basic strength you will see, nitro is an electron withdrawing group, there is nothing withdrawing, nothing releasing, and it's an electron releasing. So obviously if we want to donate the electron density, the compound which will be having the more electron density, will be the more basic one. So the answer will be 3, then second, then first, okay? And you can write this thing here, that basic strength is directly proportional to electron releasing group. Do write these things, everyone, okay? So basic strength will be directly proportional to electron releasing group. The more electron releasing group will be there, more will be the basic strength. Clear? Okay. Let's have one more question. A similar kind of, okay? You can write NH2. Here I am writing NH2 here above. You can write chlorine. There is also an NH2. And let's say here I am writing OCH3. Find out the order. What will be the answer? What will be the answer this time? You have a cyanide, you have chloro, you have OCH3 also. 4, 2, 1, 3. 1, 3. Shillong? 1, 3 or 3, 1? 4, 2, 3, 1, right? Because chlorine is there, na? Minus I will be there, yes. See, this is a cyanide, minus M, electron withdrawing. Nobody is there, nobody is giving, nobody is taking. This is also an electron withdrawing, but with the minus I, because you know that in halogens, the dominating is minus I. OCH3 is giving, this is plus M, okay? It will be giving the electron density. So what will be the order? So those who are giving the electron density will be the most basic one. So fourth will be there. After that, second will be there. And then there will be third, and then there will be the first, okay? So this will be the answer. What's happening there, Shillong? Is it raining? Oh, no, I'm just playing with the window. Okay, it's raining. That is nice. So you people are enjoying the beautiful weather over there. Even in Delhi also today there was little cloudy weather. Have you ever been to Delhi? How many of you have ever been to Delhi? How many? No? Okay, the last girls, they came to Delhi. Okay. That is nice. So you like Delhi? The last girls. You liked it? Yes, okay, so they liked it. But I don't like it, you know. This happens. So you people like Shillong more, right? You people like Shillong? Oh, so all of you are raising the hands. So nice. Obviously, Shillong is a very beautiful place. I have never been to Shillong. Coming back to the question here. See, now this is again a very good question, you know. Let's have NH2. Let's have this compound. You know the names? How many of you know the names? Nitrogen do have the lone pair here, and I'm making one more. How many of you know the names of these compounds? Anyone who knows the name of all these three? No one. No one? Anyone knows the names of any two compounds? Any two from three? No one. Anyone knows the names of only one compound? Definitely. Aniline we all know. Okay, try this question. You have to find out the basic strength here. Sisipur, you also try. Sisipur also given the answer for the last one. Sisipur, I hope you got it, right? 4-2. What I have written. Okay, 4-2-3-1. For the last one, na? Yes, 4-2-3-1 is correct. Sisipur, you know the name of these compounds? Or try with the order. Don't worry, I'll tell you. This is again a very common question, And many times, like I have drawn the structures here, but they will be asking you with the names, that what are the names of these ones. And we have done the name of that last one compound earlier. Okay, look at the screen. I am writing the names here. See, this is first of all aniline. This is pyridine. Pyridine is the name. All of these three are aromatic compounds, okay? We know the two compounds. Very good, CC4. And the last one, this last one is pyrrole. This is pyrrole, okay? So these are the names and all these three are the aromatic compounds, right? So, but you have to check for the basic strength. Now, you know what happened? Now, if these all are aromatic, obviously these will be the sp2 nitrogens. So, nitrogen is common over here. All of them has the sp2 nitrogen. So, how will you check? Everyone look at the screen, I am telling you. See, this is the lone pair, right? And it will participate in the ring. It will participate in the resonance. But always remember, what happened here is, there is the resonance only due to this type of pi bonds. Because everything is similar. It's a kind of a benzene. Only the thing is, I have replaced the carbon with the nitrogen, okay? So I'm saying that there is the aromaticity due to those pi bonds over there, okay? And this lone pair does not take part in the conjugation. Because how will you draw the resonating structure? You cannot draw the resonating structure if you have that particular lone pair into the resonance with the pi bonds, okay? So I'm simply saying, everyone, as we draw the benzene, as we know that there is the resonance in benzene, the only thing is now we have nitrogen. But it doesn't matter that if we have the nitrogen over here, still the resonance is there, and that too with the 3 pi bonds only. So in the pyridine, the lone pair is localized. So it's a localized lone pair. Okay? But if I ask you that in the aniline, will the lone pair is localized? You will say, no ma'am, it will take part in the resonance. It will not be localized one. Same is the case in pyrrole. Pyrrole is also an aromatic. You remember that for Huckel rule we have done. Everyone look at the screen. The Huckel rule we have done. So there will be the complete resonance when these 6 electrons density will be there. Look at the screen. 1, 2, 3, 4, 5, 6. So 6 pi electrons will keep on revolving, okay? So it means that in the pyrrole, the nitrogen lone pair will take part in the resonance. Because if it will take part in the resonance, only then there will be the resonance in the complete structure, okay? So I am saying that this lone pair is making the system aromatic by having the proper delocalization. So this is delocalized. Now can you think about the order? Can you tell me that which will be the most basic one? Those who have the lone pair over themselves, those lone pairs are not participating in the resonance, they will be what? They will be the most basic, right? So what about the order? Try. The most basic will be, wait too long, yes, second will be the most basic, but third will goes in the last, okay? Let me tell you why. I'm saying that this is so clear now, that second will be the most basic, because out of the 3 structures, the second is having the lone pair, which is a localized one, okay? Now, see what is happening. If I draw the resonating structure for the first one, like for this one, if you draw the resonating structure, Shillong, what will you see? When there is no doubt the resonance will be there, but instead of having the stability, when you draw the resonating structure, the ring will lost its aromaticity, okay? So one thing is this one. Now one thing more which I am saying, that this particular nitrogen lone pair when delocalized, only then the ring becomes the aromatic. So aromaticity is a very, very good thing. The compounds will always want to become the aromatic, it always want to become the stable. Can you say that in any condition this nitrogen will agree to give its lone pair to the hydrogen? Definitely not, okay? I'm saying that in the last structure, in this pyrrole na, that lone pair is making the ring aromatic. So there is no chance that pyrrole will give its lone pair to the hydrogen there and becomes, see, if it gives its lone pair to the hydrogen, it will becoming like this type of structure. Here it already one hydrogen is there, so this will kind of think, okay? Already there is one bond with the hydrogen, na? So I'm saying that now, after, making the bond with the hydrogen, this system will no longer be an aromatic compound. That is why it will go into the last. The answer is 2, 1 and 3. Okay? The answer is 2, 1 and 3. And you can write these things that lone pair is making the pyrrole aromatic, so it will not be giving its lone pair. Okay? And sometimes, I should say many times, the question is asked from the names itself. That aniline, pyridine and pyrrole, then which will be the most basic one? Or tell me the order for these three. So you should know the structures as well as the order. Okay? So I am writing here that due to the lone pair, delocalization, the compound is aromatic. Therefore, it will not give its lone pair. Do write all these things. These are the explanations, okay? Done, everyone? I hope everybody got the question, okay? And do star mark it. This is an important one. This 9 number question is an important one. My stars doesn't look so nice, but you can make them in a proper way. Okay? Yes. Now I'm going to ask you one more very important question. You people will tell me. Let's say if I have a 3-degree amine. Instead of the carbon, I should write nitrogen here. You understand now? You know the difference between 3-degree, 1-degree and secondary, primary, tertiary amines. When a nitrogen have NH, it's more like this one. When it have CH3, CH2, NH2 kind of thing. Okay? So you know this thing very well. This is a 3-degree amine, this is a 2-degree amine, this is 1-degree amine. And I can, if I want, because there is no space, I can write even ammonia after that. What will be the order of basic strength here? What will be the order of basic strength here? Tell me the answer quickly. So what is the answer? Kenny is typing the answer. 3, 2, 1. 3-degree, 2-degree, 1-degree, right? You are writing this thing. No? What? 3-degree, 2-degree, 1-degree? Okay, how many of you are with the 3-degree, 2-degree, 1-degree? Raise your hands. 3, 2, 1. Why? This is a very strange kind of order I'm hearing. What is the answer, Shillong? Okay, raise your hands, those who are saying that the answer will be 3 degree, 2 degree, 1 degree. Raise your hands. Sisipur Center, what do you think? Kenny, you have written 3 to 1 and now the people are saying it should be 3 degree, 2 degree, 1 degree. Okay, so I hope you got it, okay? The answer will be 3 degree, 2 degree, 1 degree. First of all, very, very important thing. I don't know you people have studied any kind of exception in these orders or not, but it is mentioned there in the NCERT also and it's very important. This time, this year, there was the question. They have asked the question, write down the order for methyl. These types of things were there and that was asking in the aqueous phase, okay? And this is mentioned in the NCERT also. Now listen to me everyone. Whenever this type of question is asked, the first question you people will ask again, that ma'am, which phase you are talking about, okay? So for the gaseous phase means simply what you have to check, you know that you have to see the electron lone pair donating ability, right? So you will say that ma'am, there is the 3,3 methyl group. So everyone, every methyl will be applying the plus psi effect. There will be electron releasing group. Here we are having only 2 electron releasing group and here is only 1. Okay. So it's clear. The order will be, in the gaseous phase, the order will be 3 degree, 2 degree, 1 degree. Simply you are checking by the inductive effect, nothing else. This is clear to everyone. 3 degree, 2 degree, 1 degree is clear. Okay, clear. I hope Sisipur it's clear to you people also. Now what is the trick? What is the tricky part? Because what happened many times, the order get changes in the aqueous phase, okay? Now I am writing this thing also. For aqueous phase, first of all I am writing the order and then I will explain you the reason. So it's now first of all we will write the order. In the aqueous phase, everyone, if we are talking about the methyl, like, the groups are methyl. And here, like this was the gaseous phase, so I can write any of the group. Ethyl, methyl, propyl. Everyone look at the screen, I'm talking about these groups. Like in the gaseous phase, I can write any of the group. Ethyl, methyl, propyl. I can have the symbol of R. R itself. R is any alkyl group, okay? For any alkyl group in the gaseous phase, the answer will be 3 degree, 2 degree, 1 degree, okay? Now, in the aqueous phase, when you particularly have the methyl, then the answer will be 2 degree, 1 degree and then 3 degree. And after that you can have NH3 simple, right? And for other groups, like for the ethyl and up to so on, or so on, the answers will be 2 degree, 3 degree, 1 degree and then NH3. This is the answer. First of all, note it down. This is the very, very important thing. Star mark it, okay? The star mark it. For the methyl only, the order is 2 degree, 1 degree, 3 degree. But for the ethyls and for, let's say, up to so on, propyl, butyl or anything, okay? The order will be 2 degree, 3 degree, 1 degree and NH3. Anybody having any... Have you ever studied this thing earlier? How many of you know this thing earlier? Raise your hands. Okay, only one. The other people? Okay, Kenny also knows. The other one? Why they are not raising the hands? We don't like to raise the hands. Then you can have any other sign language if you want, Okay, how many of you know the reason why this is happening? So long, tell me. You know the reason? How many of you know the reason? No, we don't know the reason. So we have crammed the order. Look at the screen, let me tell you. See what is happening actually over here, I hope this is clear to everyone that, when I have these types of groups now, this is clear that via the inductive effect, always the answer will be 3 degree, 2 degree and 1 degree. By having the inductive effect, always the answer will be this. The more electron releasing group you are having, the more the basic strength will be there, okay? Now everyone just look at the screen. Let's say if I have NH3, I am writing here the kind of, the orders like this. Let's say if I have CH3NH2, let's say if I have CH3, then CH, or instead of the CH3, I should write R. R would be more convenient. R is any alkyl group, right? Now look at the screen. Let's say I have RNHR, and let's say here I have R, N, R, like this. Okay. Now everyone just listen to me very carefully. It's very interesting. See, now in these three, why the inductive effect, we knows the answer, okay? But if let's say I say you just, let's say all of these are the bases, obviously. So if they work as the base, how it will look like? Everyone, look at the screen. It means everybody is accepting the H plus. Everyone is accepting the H plus. And what they will form? They will form NH4 plus, right? Here it will forming the RNH3 plus. It will be forming RNH2, this kind of plus. It will be forming RNH, R and R, and here it will be the plus. Everybody is getting that concept? So everyone is performing as a base. They are accepting the H plus and they are forming the conjugate acid. Can I write here conjugate acid? This is the thing now we have done. This is the base, then this is a conjugate acid. This is the conjugate acid. How many of you are okay with this? If I write conjugate acid, raise your hands. Clear to everyone? Na? This is so simple, so easy. Now what happened here is, we are talking about the orders in the aqueous phase. So what will happen, Shillong? It means you have put all of these amines into the water. So what will happen now? See, I have NH3, I am making this particular thing, and this already have the positive charge here. What will happen? Think about it. Whenever any positive charge is there and you put it into the water, what will happen? Don't you think the OH negative will come here and it will try to solvate it? If you people have studied the hydration and solvation, this is something related to that. I am saying there is a kind of an H bonding that will stabilize the particular conjugate acid. Are you people able to see that? Now one thing very important, Shillong. If this particular thing is stabilized by the hydrogen bonding, then it means it wants to get converted into the acid. You remember the same concept which we were applying in the acidic strength. What we were saying in acidic strength, that that acid will be a very good acid which will have a stable anion. Now can I apply the same concept here? That this will be a very good base. This will be a very good base because when it accepts the H plus ion, it gets stabilized by the water. Are you people getting it? That this will be a very good base because when it accepts the H plus and when it forms that particular NH4 plus, then it gets stabilized by the water. Okay. Now look at here in the last one, just the last one, and here below I am writing. Now I have the 3,3R groups, very bulky groups, and there is the H, there is the H, and it will get stabilized by the water. Is there any chance to get stabilized by the water here? Obviously, because there is so bulky groups are sitting over there. So they will have a push, a great push on the water. Okay, I am saying that there is no much hydrogen bonding present in the last structure. Okay, so that will be coming comparatively a lesser basic one because it will avoid to accept the H plus ion because it is not able to stabilize here. No stabilization, no much stabilization here. Okay, it's something like you can relate it like if any film star is coming outside your center and you get to know that there is some, whichever actor you like is outside your center, outside the ALS, you people will rush towards him, Why you will attend my class? Obviously, you won't attend my class, you will rush towards him. And you will try to have some selfies, you will try to have the photographs, everything is there. So you will be surrounding him, okay? But let's say that actor come, but that too with a lot of bodyguards are over there. Okay, so the bodyguards are over there, and so will there be any chance that you people will have a selfie with that actor? Obviously not. Okay, so I'm just trying to relate it. I'm saying that in this particular last structure, the water will not be able to come over here, but in this structure there are so many water molecules coming over there, sitting and stabilizing it. Okay, so if I ask you, Shillong, that now what will be the order? So this way, the solvation supports this order. This is all known as the solvation, that you are solvating it. So solvation supports the order like it should be ammonia, then 1 degree, then 2 degree, then 3 degree. Are you getting me? This is supported only by the solvation, because the corresponding acid we are getting is getting stabilized there. And via the inductive effect, what was the order? If I check only the inductive effect, the order was 3 degree, 2 degree, 1 degree and ammonia. Sorry. Okay. Now, this is why we are getting that intermediate order, because these two have the fight. There is the competition in these two orders. Okay. So, experimentally we check the pKb values over there. So the net resultant comes out to be something like we get a 2 degree. Okay, so net resultant, because one is supporting this order, other is supporting the reverse order. So we get a net outcome of that is actually the 2 degree. And what happens? See, like particularly in the methyl, after the 2 degree, it's 1 degree, because solvation is having the more priority, because the groups are not that bulky. Okay, so solvation is having the more priority. That is why I've written 1 degree. Then it is 3 degree. But if I check for the other groups like the ethyl, propyl, those are the bulky groups. So solvation is having the lesser priority. Instead, the inductive is having the more priority. So it's like 2 degree. After that 3 degree, then 1 degree. Okay. I hope a little bit of the story will be there in your mind. Okay. So, nobody is going to ask you the full explanation in the exam. This is, I've just told you because it's interesting. We should know that. And at least the NCERT talks about these things. Okay. If you check the NCERT of 11th class, they have written these terms of solvation, inductive and all these things. You got it, Shillong? Raise your hands if you got it. Okay. Nice. Everybody got it. I am happy. And CC Center, I hope you also got it. So do write these things, okay? Do write these things. I hope a order everybody has written, so you can also write. And you can just write the explanation in the way you want. Everybody has written? One topic is left here now in the basic strength. Should we do it now? Or no, ma'am, next class? Next class? Everybody is packing their bags. Everybody is raising their hands. Very nice. Very good. Okay. Okay, so I guess these orders are, so we have done a lot of things today, Shillong. Have a look, quickly have a look. We started from the acidic strength, okay, that was all the revision. We talked about the sulfonic acid, we talked about benzoic acid, we talked about the ortho effect. Ortho substituted will always be the more acidic one. After that, the reason is clear to everyone, I have told the reason. H bonding question was there, okay, orthonitrophenol, paranitrophenol. Squaric acid is your homework, okay. Basic strength we have talked about, and these were all the common questions like we were discussing in the acidic strength, right? After that, this one is the important one, okay, that order, SP, SP2, SP3, these ones with the localized, delocalized one. After that, there was one more important question of that one. Look at the screen. Pyrrole, pyridine, aniline, all these things were there. And then we have talked about the typically for the 1 degree, 2 degree and 3 degree amines, okay? Now the again important thing is, only one very, a 10 minutes topic is left in the basic strength, then we will done with the basic strength also. And in the next class, what we will be doing, let me tell you, we will finish the basic strength, we'll spend the 10 to 15 minutes on the tautomerism. Then I think before proceeding towards the reactions, it's better to talk about first something about the stereo. How many of you have the idea of the stereoisomerism? You know about the stereochemistry? Chiral carbon, optical activity, meso, enantiomer, these things we will be talking about. If you have the idea, very good. Sometimes the direct questions are also there in the exam, okay? And that will be useful for us because we will be studying those types of questions related to the stereo and the reactions, okay? So one more class, and after that, definitely we will going to start the haloalkanes, right? So that is it from my side. Please make sure that you people will be solving the question. Yes, I have the message from your physics teacher also. They just told me that I think they have shared some questions with you on the WhatsApp. So they were just asking me that to make a reminder for the student that please keep on solving the questions, okay? And by today or by tomorrow, I'll try to post the questions related to the acidic strength and basic strength also in the group, okay? So enjoy the weather with your studies, okay? See you in the next class. Bye-bye. Thank you.